We are starting our new unit, Unit 8, which is all about exponential functions. We will learn about the laws of exponents. So see these different topics: linear versus exponential, arithmetic versus geometric sequences, laws of exponents, and applications of exponential functions. So these are, again, reminders we've gone through. Slide 5, a lot of things are going to be in our composition book, and you'll just upload a picture in your journal. So let's start out with problem string 1. So a problem string is just a series of different problems, and they're basic problems that will lead us to some sort of conclusion. So we are starting with exponents as our multiplicative. So I'm going to open up my journal. So I just put this up at the top, multiplication and exponents, and I'm going to put problem string 1. That is really hard to see, huh?
A little bit.
Yep. All right, so the first thing we are going to talk about is just some multiplication problems. Easy peasy. 6 times 8. And for these multiplication problems, we're not using our calculator at all. Of course, we don't need to. But just a reminder, 6 times 8, 48. Okay, and 6 times 8 can be represented as a area of a rectangle. I'm going to count each one of these as 2. So 2, 4, 6 times 8. I'm counting those as 4. And we know that the area equals 48. Units squared, but we're not worrying about that right now. So we're kind of looking at some area models. The next one is 8 times 6. That's the same thing, right? 48. So let's draw that area model. Okay, so let's think about how we could also get 48, but using 2 different integers. So what if I take 8 and I divide this by 2? It's 4. But then I take 6 and I multiply by 2. 12. What is 4 times 12? 48. So let's do that area model. So again, we're counting each box as 2. So this would be 4, and then we'd need to go 6. No, 12, which is 6, sorry. And so we know that that is also 48. Okay, what about 3 times 16? Yeah, that one's 48 also. You'll see the trend here.
Yes.
All right, so 3, we're going to do like 1.5. And then 2, 4, 6. Good catch. I'm not used to doing it on this grid and using different scales. All right, is that right now? 1.5 means 2, and then 2, 4, 6. 2, 4, 6, 8. My goodness, y'all. All right, there we go. Okay, what is another combination that gets us 48?
1 times 48.
1 times 48. Is there another one, though?
2 times 24.
Yeah, so 2 times 24. So there are different factors of 48, different ways to get the product of 48. So let's see what else we can do. Let's see. What about 2 times 2 times 2 times 2 times 3?
That's 2 to the fourth power.
That's 2 to the 4th times 3. Okay.
We're doing this. Oh no.
So remember how in the beginning it said exponents are multiplicative? What does 2 to the 4 mean?
It's 2 times 2.
Yeah, 2 times 2 times 2 times 2 times a 3. So if I wanted to do 2 to the 4th, I'd do 2 times 2
4
times 2 times 2. 4. 4 times 4. What's 16 times 3? 48. Okay, let's write some equivalent multiplications. So we know that 6 times 8 is the same as 8 times 6, right? Let's break it down into this, but do our groupings. So let's do 8 times 6. How would I group these together so that I get an 8? How many 2's multiply together to get 8? 3. So 2 times 2 times 2, that's 8. And then what about, how do you get 6? 2 times 3. Okay, so that's just breaking it down. Let's look at 4 times 12. So let's use the same 2 to the 4th times 3, but let's break it down. How do you get 4? 2 times 2. And then how do we get 12? 2 times 6, but we're going to break down 6 into the 2 times 3. 2, because that would be 4. 4 times 3 is 12. Okay, let's do 3 times 16 and break that down. Can I do 3? 3 with anything? No. So 3 times, how do we get 16? 4 times 4.
2 times 2 times
Right, which breaks down into 2 times 2 times 2 times 2. Okay, the last one is the 2 times 24. That goes with this grouping of the area models. So how do I break that down? 2 times, how could we get 24?
2 times 2 times 3 times 2 times
Times 3, yeah. Because what's 2 times 2 times 2?
It's 8.
8 times 3, 24, yeah. Okay, these all represent 48, but they're written in different ways. Let's look at 2 to the 4th times 5. How can we write that? 2 times 2 times 2 times 2 times 5. Okay, remember we're not using our calculator. We're just going to work it out. So these can be grouped in different ways, right? This could be grouped as 2 times 2 times 2 times 2 times 5. It could also be written as, what else? 2 times 2 times 2 times 2. Because how many 2's are there? 4 times 5. It could be written as 2 to the 3rd times 2 times 5. So let's go ahead and find out what that is. What is 2 to the 3rd? That should be one that we just know automatically. 8. What's 2 times 5?
10.
10. What's 8 times 10? 8. So what is the most efficient way to write these problems? Is it efficient to write out all these 2's? Or what would be more efficient? Exponents. So how could the 48 be written?
2
times
1 and 4
Yeah,
times 3.
times 3. So that's the most efficient way to write it. So exponents help us with efficiency. Writing all these out wasn't very efficient, was it? No. But it showed us that you can write a number like 48 in many different ways as products. Okay, so let's look at so you will end up putting a picture of this in your journal. In your digital journal. Let's look at trees and acorns. I need to show y'all a video first. Okay, this has no sound. No, yes it does. Hold on. Let me turn it up.
Hey, how's it going?
It's almost March.
What does that mean?
I get to watch my favorite sport.
Oh, right, basketball.
No, I actually play basketball.
That does not look like you.
Swish!
So you like to watch the NCAA tournament with all the college teams?
Yeah, it's called March Madness.
It's fun to guess who will win each of the games. Look, there's my favorite team. Go Cougars!
My favorite team's gonna win.
That's a lot of teams. How many is that?
There's 64 teams that start.
So they each play a game. There's one winner for each game.
Half as many teams still playing, so 32 teams left.
Then they each play a game. Let's see.
Only winners are left, so half of 32.
That's 16.
Yeah.
And half of 6 teams are left. That's
The Elite 8.
Sweet 16, Elite 8.
Whole pattern in the graph.
My team won again.
So did mine. And that leaves 4 teams left. The final 4.
Sweet 16, Elite 8, Final 4. Oh, I get it. Terrific 2. Take that 2. Triumphing 2.
For a championship game.
I wonder who will win.
Let the better team win.
That's a cool pattern. Hey, help me with my homework. I'm supposed to investigate plant populations. Do you have a favorite tree?
Oak trees.
Why?
I like the heads the acorns were.
So if an oak tree drops an acorn and a new oak tree grows, we had 1 tree, now 2. The population doubles.
Keep track of those numbers.
1 oak tree drops an acorn, and then we have 2. 1 tree doubles. Each of those trees drop an acorn, and we double again, 4 trees. So you took what you had before and doubled.
I think the heads look like little berets.
These trees all drop an acorn. Double the 4 trees is...
8. 8 trees.
That's what I had before, double.
You can
be
write that
watching the
more
video.
efficiently. Called exponents. 1 times 2 cubed.
Oh, that is nice.
You doubled again. 16.
Yeah, so that's what I had before, but doubled.
4 to the 4th.
Right, then each of those trees drop an acorn, and double 16 is 32. Oops.
Need to use a bigger scale.
Yeah, hang on. Okay, I've rescaled and stuck all of our data down there. Now, I can fit the 32. And that's what I had before, double. And that's 2 to the 5th.
Yippers.
Now watch how fast I draw these. Ugh. Fine, I'll rescale quickly, and this time I'll give myself a ton of room. This doubling sure takes a lot of room. Okay, now the 64 shows up just fine. So, what I had before and doubled,
That's to the 6th.
now 64 doubles to 128, and it fits too.
Nice job.
I'll just write it as an exponent. 2 to the 7th, right?
Uh-huh.
Those trees double to 256 trees.
Barely fits.
I had 7 2s before, so 8 2s, 2 to the 8. Uh-oh.
I don't like the sound of that.
The trees aren't supposed to double. They're supposed to triple.
Yeah, you can do the rest on your own. I'm out of here.
Okay, so let's talk about the
Look,
different
there's the
situations.
So they eat.
So one of the situations was March Madness. How many of y'all watch March Madness? Is there any of y'all? Yeah? So have you ever thought about how the team numbers decrease? I know we've all heard of the Sweet 16 and then Elite 8, Final 4, and then your championship game. So it's going down. See the pattern? Is that linear? Does that look like a line? Nope. So this is more of a curve look, right? Okay. And then the same thing with the trees and the acorns. I thought it was funny how he was talking about the acorns and the beret, the hat that's on the acorns. Kind of corny, but funny. So what about this one? This one's increasing. Is this linear?
No.
It kind of looks like right here, right? But then it's like, woo, like shoots up. So let's look at our slides. Let's see. So the little friends, they were saying it doubles every time. But then at the end, they realized, oh no, it was supposed to triple. So let's look at if the trees triple. So if the trees triple each generation, find the number of trees in the first few generations and look for patterns. So we have this to start out with. Then it's going to triple. I made these little trees. Look how cute they are. All right, so it's going to triple. So we start out with 1, and then how many will we have when it triples? 3. So I need to add 2, right? So how many acorns do we have now? 6. So 2, 4, 6, but it's supposed to triple. So times 3. So in the first pattern, we have 1, and then it triples. So we have the 3 trees, and then it's going to triple again. So how many will we have then? 3 times 3 is 9. So how many more do we need to add? 1, 2, 3, 4, 5, 6, 7, 8. So I need to add another one. And then it's going to triple again. So how many will we have? So right now we have 9. How many will we have when it triples? 27. Y'all want to keep on doing the little trees? Not really. But we can do a table of values. So we have repeated multiplication or exponents, number of trees. So we start out with generation 0. You have the 1 tree. And then after 1 generation of trees, we multiply it times 3 because it's tripling. That's where we get the 3. Second generation, we are going to multiply by 3 again, and that's 3 squared, which is 9. So let's fill in the table for the next one. So this will be the third one. So put a 3 there. I already have text boxes for you. So then the repeated multiplication would be 1 times 3 times 3 times 3 more. Which we can write that as an exponent. We can leave the 1 off, and we can write this as 3 to the 3rd power. You're going to have to expand this a little bit. Do y'all remember how to do the exponents? Command and then the greater than symbol? Oh, yeah, control. On Macs, it's command. And then what did that equal? 27. So it's like we are doing 1 times 3 times 3. I did the little scribble tool to do that. And then 3, it's tripling. So we're going to do it again. So it's times 3 again. Times 3 again. Okay, what about the 4th generation?
1 times 3 times 3 times 3 times 3.
How many 3s do we have now? 4. So 3 raised to the 4th power. And what does that equal? Well, it's 27 times 3. 81. Good job. Okay, so let's track it in our graph here. We need to go to at least 81 so we can get 4 generations on there. Do y'all want to do this in our journal? Yeah. So I'm going to just use up at the top of that problem string. I have a little bit of room that I can do over here. So I'm going to label it trees tripling. And make a little quadrant 1. So we know that the x-axis is going to represent generations. And the y-axis is going to be number of trees. So what are we starting out with? And what do we need to go to on the generations? So generations is our x. So we're starting out with 0 and going to 4. So let's label them 0, 1, 2, 3, 4. Okay, and then our y-axis is the number of trees. So let me see how many I have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I have 10. Go by tens? What do y'all think? I think that'd be easiest. So 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. Okay, so 0 starts out with 1. So it'd be down here. And then the next one's 3. 1, 3. 2, 9. 3, 27. And 4, 81. Okay, so see how it increases really rapidly? I'm going to use a pencil to kind of follow that graph. All right, pretty cool. I think that graph looks cool. It's very different from anything we've done before. So now what you're going to look at, oh, you need to put that picture here. We are going to look at would you rather. And this is what you're going to do as your assignment. Would you rather? To grow a forest quickly, would you rather start with 10 trees that triple in each generation or start with 3 trees that multiply by 10 each generation? So this is your assignment to do right now. You can talk about it with your table group, and then we're going to talk about it tomorrow as a whole group. And you can use the next page in your journal to create